Hello everyone, in this video we will work on this case. So basically we are trying to develop a model that is able to predicting the housing prices, and also we are curious to looking for, okay, what exactly are the variables that might have a significant relationship with the price. Okay, a real estate agent called Edinburgh Realty in Erie, and you are the manager in this company. You want to know what will affect the house price. You collect the data from 378 homes in the whole Pennsylvania. The data for each home sold included the sales price, the size of the home, the number of the bedroom, the age of the house, and the location of the house. So we're looking for three hypothetical locations in Pennsylvania, Edinburgh, Dallas, and Pullman. And as you notice that the descriptive of each variables have measurement unit, and they sometimes become very important because in this exercise later we are gonna go into predicting the housing prices. You have to understand for each variable what is the measurement unit. So our y variable, obviously our dependent variable here is our price. So it's a sale price is measured in dollars. And then our the first predictor or explanatory variable is called the square footage. So it's my x1, and it's measured by square feet of heated floor space. And so we are not actually just looking at how large the area is of the house. We're actually focusing on the heated floor space. And then we are x2, which is our second explanatory variable. It is number of the bedroom. And then x3 is our the age of the house. So it's so at this point from the beginning when they start building the house to now, how old the house is. And then also, like I said in the description, our last variable is supposed to be house location. So it is a categorical data. So instead of using categorical data directly, we actually need to creating dummy variables. So if you do not remember what is dummy variable and what is the concept of dummy variable, please watching the lecture videos where we spend a lot of time to discussing, okay, what is categorical data and how can we creating dummy variable for the categorical predictors. Okay, so in this case, I already predefined my dummy variable for you. So since for the location I have three potential value, Erie, Dallas, and the Pullman. So we only need the two dummy variables. So if you're going to ask why only two, again, please watch the lecture videos where we are explaining further on to help you understand how many dummy variables you should create if you are collecting your own categorical data. Okay, so x4 is my dummy variable. We use x4 to indicating if the house located at Erie City or not. If it is in Erie, it's 1, 0 otherwise. And x5 is my dummy variable. There's a typo here, so it's x5. If it's equal to 1, that home is located in Dallas. Otherwise, it will be 0. So some student are going to ask, oh, how about the house is located at Pullman? So we're going to look at Excel file later to see, okay, so how we actually going to dummy coding for the house at the Pullman. Okay, so for this case, we have 8 following up questions. As I describing here, the 8 step is step by step to help you understand how you should carry on the regression analysis. So in this specific video, I will focusing on first of all creating dummy variables, and then the second is solving our first question, determine the simple linear regression that only consider x1 and interpret the slope. And so question number 1 and 2, usually we only need question number 2 since we are trying to explaining how the regression model works. So we're starting from our we are starting from our simplest model. We only have one predictor in our regression model, so that is called a simple linear regression model. Okay, so let's look at our data set together. As I mentioned that in our a column is my y variable, so that's what I usually like to do is creating my my label so that later on I'm not misusing my variables. So my y variable is price, this is my x2, and then this is my x3. Okay. We will handle the location later as we move on to the next question for the multiple linear regression model. Since this one, we only focus on simple linear regression model, let's just keep the data as it is. So our y variable is a column, and our X variable is B column. Okay, how can we get in our regression output? So what you need to do is on the data tab, data tab on the right hand side, you'll be able to see data analysis. So we already use this plugin in our previous modules. So once you set up Excel, you should be able to see the data analysis. So you only set up once. So if you don't see the data analysis here, it might be hidden under this one. Make sure you full screen your Excel file. And then the second is if this is your brand new computer, you never used Excel on this computer, so you have to follow the previous modules video to learn how to add on this add-in called data analysis. So here what I will do is just demonstrating how we can get the simple linear regression model. Okay, under the data tab, click the data analysis. So here we will choose called regression. Okay, we pick the regression and then we click OK. So here it's very important that you are correctly choose your X and Y variables. So if you incorrectly choosing your variable, your regression model will be totally wrong. Okay, and for my preference, I do like when I choose the data, I will include in my labels. So therefore, you need to check the box labels. So let me select the data first. So for the Y range, so I put my mouse here and I click this upward arrow. It allows me to select the data. And I will select from A1. We have many observations here. So to A379. And then push this little arrow one more time. Now we are able to select our input range and we'll click this little arrow. And then choose from B1 to our last B378. And then you push this little arrow. Perfect. And then check this box called the labels, right? And then after you do that, let me scroll up. Okay, it doesn't matter. So here, let's give I like to put my regression output in a new tab so it's easy for me to navigate or to find them. So let's see, this is for my question number 1. Okay. Question 1. And then just build a good habit. I usually want my student getting the residual, standard residual in the line fit plot. And then let's just check, and also the last one. So later on in the regression analysis, you're going to look at how can we testing out the model assumptions. So we will need all those information. And then so just check residual, standard residual, line fit plot, and normal probability plot, and check all of them. And then you can click OK. Okay, as you notice that we are able to see many output here. So my data task is help you to find the information you needed to answer our first question. Okay, so first of all, let's just make sure you know, sometime on Excel, they will have this kind of weird expression or have the E. This is called a scientific notation. So what I recommend my student to do is usually like basically based on the question, you are able to understand how many decimal places you needed. And so what you should do instead of write 5 point, like get so confused with the E in your output. And so you can do is click this big giant triangle. And then after you click that, it's allow you to select the whole spreadsheet and then right click the mouse, choose format cells, and then go into number. It allows you to select how many decimal places you wanted. I prefer to choose 4 because I have right amount of the decimal places. If the question requires me only keep 2, and I can very easily to see what is the two decimal places should look like. But also 4 usually by default in a lot of counting space, they do want you to do 4 decimal places. So therefore, let me just pick 4 as how many decimal places I'm looking for, and I click OK. Okay, so after I do that, you notice that all my ER disappeared because all those E are my scientific notation. Basically, E is the, for instance, 2E negative 10. So that is 2 times 10 powered by negative 10. So basically, the number after E is the power of the that 10. So it's very confusing sometimes you read it if you're not. So by doing this way, I just show you, it allows you to read those E numbers. Okay. Okay, so the question is, where can I find my regression equation, right? So at this point, I'm assuming you have to already watch what the regression equation should look like. So in the Excel output, there were like three sections. So there is one section here, it allow you find R square. And the section here we call ANOVA table. But the most important thing we're using in this table is to do the hypothesis testing for our global F test. So we are able to find the p-value here. And then the third table here, I like call it a regression equation table, because in this third table, it allows us to find where is my regression equation and the regression equation related information. Okay, first of all, let's focus on this the column here. So this column here is called the coefficient. It allows us to find our B0, B1, B2, etc. Right? So since we are working on the simple linear regression model, we only have one predictor. So that's my square footage of our heated floor, right? So therefore, the first row, the information here are all related to the B0. Okay, and then the second row here, although we call it x1, but this is our slope, because the slope is related to our square footage of heated floor. So the coefficient, this column, will give us the value for B0 and, sorry, so this is B1, this is a typo. So this is going to be my B0 and this is my B1. Okay, now the question is, how can I answer the question here? Question number 1, determine the simple linear regression equation. So what you need to do here will be, okay, let me just open a new. Okay. So question 1. So my answer will be equal to y equal to, let me go back to my Excel sheet. So this is my y b0. Remember in our lecture, it's a b0 plus b1 times x1. Okay, so basically y will equal to, we find a b0 from the Excel output, plus this is going to be my slope and the x1. Okay, so don't forget for this class, we do focusing on how to interpret the result. So what is this B0 actually mean? That means if we don't, if any houses, the heated floor square footage equal to 0, we're expecting the average house price is 22,324. And now, however, we are asked to interpreting this slope, which is the B1. So the B1, if you don't remember, make sure you watch our lecture video again. So the way we're interpreting B1 is as the square footage of the heated floor increases by 1 square foot. The house price will increase by $37.0159. So that is how we interpreting our question slope. So basically is if as x increased by 1 unit, and that is how y will respond. So this is how you should interpreting the slope if we are working on the simple linear regression model. Okay, so this is the question number 1, and hopefully it is helpful for your homework and also your our forthcoming case case study exams. So in next video, we're going to look at question number 2.